Hello friends, subscribers and new viewers of this channel, and welcome to Robot Operating System version 2 tutorials. In this Robot Operating System version 2 or ROS2 tutorial, we explain the basics of ROS2 by using the Turtlesim simulator that you can see over here. In particular, this ROS2 tutorial is developed for the ROS2 Jazzy Jalisco version. Jazzy Jalisco is the most recent version of ROS2, and I suggest to everyone to start learning ROS2 Jazzy Jalisco. On the other hand, Turtlesim is a simple model and simulation of a 2D mobile robot. This example is used to illustrate and learn the main ideas and concepts of ROS2. Consequently, if you're completely new to ROS, you should start with this example. Later on, you can build your own mobile robot and apply the learned concepts to the real hardware. Now let me explain what's happening over here. As you can see over here, I'm controlling this small turtle animation over here. And to control turtle, I'm using my keyboard keys. Namely, if I use the arrows, I can move left, right, rotate, move forward, backward, etc. And in reality, you would control your mobile robot like this. In this tutorial, we explain number 1, how to start nodes in ROS2, number 2, how to start a Turtlesim node in ROS2, number 3, how to start a teleop node in ROS2 that will enable us to control the Turtlesim in ROS2, number 4, how to obtain information about the nodes, topics, services and parameters that are currently running in the ROS2 system, and number 5, how to use the RQT graph to visualize the topics, nodes, actions, and the structure of the ROS2 system. In order to watch and implement everything explained in this video tutorial, you need to have two things. First of all, you need to have Linux Ubuntu 24.04 installed on your system. You need this version of Linux Ubuntu to run and install Jazzy Jalisco, and secondly, you need to install ROS2 Jazzy Jalisco on Linux Ubuntu. If you don't have Linux Ubuntu and if you don't have ROS2 Jazzy Jalisco, then don't worry, you can watch my tutorial in order to learn how to install them. First of all, this tutorial over here will teach you how to install ROS2 Jazzy Jalisco on a Linux Ubuntu 24.04, and I'm going to provide the link in the description below, as well as the link that will explain you how to install Linux Ubuntu from scratch. Okay, let's immediately start. First of all, open a terminal, and over here I'm going to resize this terminal window such that you can see what I'm typing. At the same time, you can follow the manual given over here. First of all, you need to have Linux Ubuntu 24.04 in order to run ROS2 Jazzy Jalisco. To verify your Linux version, type this. And over here you should see Ubuntu 24.04. If you don't have that version of Ubuntu, you need to install it. Next, you need to verify that you have ROS2 Jazzy Jalisco installed on your system. To do that, you need to first of all try to execute this command. And if you can execute this command without no error, then most likely you have ROS Jazzy Jalisco on your system. However, better confirm it like this. And if you see Jazzy, it's good, you have Jazzy Jalisco, or even better, type this. And this will print everything about your ROS2 Jazzy. And if you see something like this, this is good. On the other hand, if you don't have ROS Jazzy Jalisco on your system, then don't worry, I created a separate video tutorial explaining how to install ROS2 Jazzy Jalisco on Linux Ubuntu, and a link to that tutorial is provided in the description below. Next, let's clear the screen, and the first step is to source the environment and install Turtlesim. Namely, whenever you want to play with ROS2, you need to run this script over here, setup.bash, and you will do it like this. Okay, next, let's verify once again the environmental variables. Again, we can do it like this. This is good, everything is fine, and let's continue. Next, let's update and upgrade everything before we install Turtlesim. Type this and enter your password. Next, we need to install ROS Jazzy Turtlesim. To do that, simply execute this command. On the other hand, if you're using some other ROS2 distribution or ROS2 version, here instead of Jazzy you will enter the name of that distribution. For example, if you're using Humble, you will type Humble over here. However, my suggestion is not to use Humble. Good. Let's verify that Turtlesim is installed. To verify the installation, let's run this command: ROS2 package executables Turtlesim, and if Turtlesim is installed on your system, you should see these executables and packages. Good. Next, let's learn how to run the Turtlesim simulation. To run the Turtlesim simulation, or to be more precise, to run the Turtlesim node, we need to execute this command over here. And let's see what will happen. Wow, here it is. Here's our simulation and animation. So let's explain a few things over here. I said that we are running the node. Okay, so this is a node that you can see over here, or better to say, this is the visualization of node. In ROS2, nodes are programs or modules that are responsible and that govern behavior of a certain subsystem. For example, in a mobile robot, we have a number of nodes. Every node is responsible for a particular subsystem. For example, we have a node that is responsible for controlling wheels and different sensor nodes, such as the nodes responsible for collecting the distance, camera node, lidar node, and the node responsible for localization. Nodes communicate between each other by using topics, action, services, and parameters. So over here you can see a visualization of a node that's being started. This node is responsible for animating the motion of our turtle and also receiving commands that will control this turtle. Next, let's analyze what is written over here in the terminal after we executed this command. We can see several interesting things. First of all, we can see over here starting Turtlesim with the node name Turtlesim. Good, now we know the node name. And we can see spawning turtle, turtle1, that's the particular name of this node at x, y, and theta coordinates. So what is x, y, and theta? X and y are the coordinates of the turtle with respect to some coordinate system in this 2D graph. For example, maybe the coordinate system is here or here, here or here. It really doesn't matter. And what is theta? Well, theta is the orientation or the angle of the turtle. Namely, over here, turtle is spawned with the angle 0. Okay, this is very important to understand. However, can we control this turtle? Try to use the arrow keys on your keyboard, nothing happens. So why is that? Well, to control the turtle, we need to have another node. And the name of that node is a teleoperation node. And this is the standard node in almost any ROS2 system, such as mobile robot or even an articulated robot. Namely, you need to have a special node that will receive the key commands from your keyboard or your joystick, and that node will control this turtle over here or your robot in real application. Next, let's learn how to run the teleoperation node. To do that, click over here, open a new terminal, then again source your environment, bang. Then over here, to run this node, you need to type this. And let's explain what's happening. We are running the node by using ROS2 run. Then we are specifying the package Turtlesim, and we are specifying the name of the node, turtle teleop key. Bang. So what happens now? You will see this message: use arrow keys to move the turtle. Use these keys to rotate to absolute orientations. However, we are just going to use the arrow keys. Okay, so let's bring back our turtle. Make sure that you can see the turtle. Minimize this terminal and make sure that you click here and that you are in this terminal in which you run the teleop node. So let's now start pressing left, right key, arrow, left, right, up, down, and this is how you can control this nice turtle So play with your arrows on your keyboard and you will be able to control the turtle. You can also use some other keys such as C, D, etc. to control to some absolute position. Good. Next, let's learn how to obtain information about nodes, services, topics, and parameters in ROS2 systems. First of all, make sure that both terminals are opened. And then open a new terminal, and again, whenever you want to use any ROS2 command, you need to source the environment. Okay, after sourcing the environment, let's see all the nodes on our system. To do that, you need to type this command, and you will see two nodes. The first node is teleop turtle, and the second node is Turtlesim. Good. Okay, this means that we currently have two nodes that are running at the same time. As explained previously, Turtlesim node is used to simulate the turtle, and the node teleop turtle is the node that reads the keyboard inputs and sends the control information to the Turtlesim node. Later on, I'm going to show you how to visualize a graph that represents the connection between these two nodes. So let's obtain additional information about a particular node. So let's type this ROS2 node, and let's use info, and then let's specify the name of the node, Turtlesim. Let's see what happened over here. You got a bunch of interesting information. You can see subscribers, publishers, service servers, and very interesting information. I'm going to cover this in the future video tutorial, such that you understand everything what is written over here. Good. The next step is to see the topics. So what are the topics? Topics are communication channels that are used to communicate information between nodes. Namely, the teleoperation node has to send some messages to our Turtlesim node such that Turtlesim can move. And for that purpose, we use topics. So let's see the list of all the topics on our ROS system. And you will see it like this. So here are all the topics. We have parameter events, we have ROS out, we have Turtle1 command velocity, we have Turtle1 color sensor, and Turtle1 pose. In this particular tutorial, I'm going to only cover Turtle1 command velocity, since this topic is very important for understanding how ROS2 works behind the scenes. In the future video tutorial, we are going to cover other topics. Okay, so let's see another thing. So what happens if I type now ROS2 topic list -t? Then you will see, in addition to the name of the topics, you will see the type of messages that are being communicated over topics. Namely, ROS2 is a programming language, and ROS2 has standard data structures that are used to communicate between the nodes and to send information between the nodes and to store information. In our particular case, Turtle1 command velocity is expected to send and to communicate this message. It is geometry message twist. That is inside of geometry message package. This is a standard ROS2 package. There is a message, and this twist is actually the data type. And this is very important. You can also obtain the same information if you type something like this. And now you know more, you can obtain more information about what is being communicated through this particular topic, command velocity. Again, command velocity is used to send information from teleoperation to our simulation. So we can see the type of messages, we can see how many publishers are being currently publishing through this topic, only one, and that's our teleoperation node, and how many nodes are being subscribed, only a single node, that's our simulation node. And this is very, very important. So let's explain what is this geometry messages message twist. Namely, ROS2 has standard data structures that are used to communicate information between nodes. These data structures are called messages. In our case, we are communicating geometry messages of the type twist. More precisely, when you see something like this, geometry message, message twist, means that in the package called geometry message, there is a message called twist. Okay, so let's obtain more information about this particular message and about the data structure. So let's see, ROS2 interface show, and then we need to specify the name of the topic. And let's see what happens. Bang! We see the following. This expresses velocity in free space broken into its linear and angular parts. Now, if you studied mechanics, you have probably learned that we have linear velocity expressed as a vector in a three-dimensional space, as well as the angular velocity vector, again expressed as a vector. Okay, so every vector has three components, and you will see the components over here for the linear velocity and the components for the angular velocity. So in our case, we don't have the z coordinates, so we will have x and y, and over here for the angular velocity, we are only rotating around the z-axis, that is around the axis that's perpendicular to our screen, and consequently x and y components of the angular velocity will be 0. This is very, very important to understand. So, what happens behind the scene? This node over here, that is our turtle teleop key, is reading the keyboard keys, creating a message that has these components, and sending this message to this node over here. That is to our simulation node, and at the end, the position is being updated and the orientation of this object is being updated on the screen on the basis of this information. Okay, let's now see in real time what's being sent. So how to do that? Well, we need to echo the messages that are being sent through a particular topic, and to do that we need to use this command. So again, let's open a new terminal while keeping these terminals active. And let's first source the environment. Okay, and then let's run this command. This command, ROS2 topic echo, will echo or print on the screen the messages that are being sent through a particular topic. In this case, the name of the topic is Turtle1 command velocity. So let's press enter and let's see what happens. Nothing happens. So nothing happens here because we are not pressing anything. To press something, click over here, or better click over here, that is go to the turtle teleop key terminal and start moving. Okay, now I'm moving, and if you go back to this terminal in which we run the echo command, you will see what happened. You will see precisely what are the messages that are being sent, and you will see the history. And then you can even log these messages and show them in some file. And you will see at the moment when I press, let's say, the left or right arrow, you will see here that z angular velocity is being updated, and we had rotation over here, and then we moved left or right. For example, over here we move maybe left or right, up and down, and you will see linear component of velocity. And that's it. This is a very useful. And to finalize everything, let's learn how to visualize the structure of our ROS system. For that purpose, open a new terminal, then over here update everything. I will enter a password. Then let's not forget to source the environment. So let me now go back and use the source command that we wrote over here, where it is, blah, blah, blah. Let's go a little bit up. Let me see, where is the source command? I mean, I can even type it by myself, but I'm currently a little bit lazy to do that. So I will again source this, and then we need to run this command. Let me go and show you. Here it is. This command is going to install the RQT as well as the graph. And to start the RQT graph, you'll simply run this. Bang. And let's see what will happen. Well, you will immediately see over here the structure of your system. We have Turtlesim node, we have the teleop turtle node. You can see how they're communicating. they're communicating through this topic, and over here you can see some additional information that I will explain in the future video tutorials. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.